All right, so here we go. We're going to practice for the law of cosines quiz. Everybody's paying attention.
This is tomorrow.
It's tomorrow. And we've already spent some time with the law of cosines, but we're now going to take a quiz. So, once again, I had a full page, so I put 2 problems on here. Your quiz will be just 1, okay? So, we're going to do 2 to practice, but you will just have 1 triangle to solve on your quiz. All right.
Okay.
So the first thing we think, text, you've been disruptive enough. Turn around, focus, let's go. Let's get ourselves in uniform. I should see lanyards, I should not see coats. It's not sub-zero outside, folks. Is that a college sweatshirt you're wearing, Tex?
Yes.
A college sweatshirt.
Oregon State. Go Beavers.
Okay.
Period.
You're missing a key component. Is this what we would call a sweatshirt?
It's a jacket.
Doesn't matter. It's gotta be called sweatshirt. Take it off.
No. I'm sure.
You don't have anything underneath it?
No. I mean, it's a jacket.
Okay. And does the uniform say college sweatshirt? Or college jacket?
I've worn this many times before.
Well, you know what? Maybe if you hadn't come in after flex and had to use the restroom, I wouldn't have noticed. Okay. Law of cosines. I better see lanyards on everybody too, or we're gonna get a detention. He's not here.
Okay, thank you.
Shiloh, where's your lanyard? That's not acceptable. Yeah. Guys, it's not a hard rule. What is the issue? Garrett Stewart?
Mine's in the left hand and it's still on.
All right, here we go. Now, the first thing, I know the quiz is going to say law of cosines on it, so you know you're going to do law of cosines. But thinking into the future, on the test, you just have a bunch of triangles. So you need to be able to look at the triangle and tell whether you're going to start with the law of sines or the law of cosines. You're always going to start with one or the other, okay? Yes, you can use SOHCAHTOA on on certain triangles, the right triangles, but between the law of sines and cosines, that will solve everything you need. So, how do I know this is a law of cosines problem? There is no pair. And by pair, we mean the angle and its side. So draw a circle like this. Do you know both numbers? No. Do you know both numbers? No. Do you know both numbers? No. If I knew this was 53, for example, then I'd have a pair, right? But I don't. So because there is no pair, this is going to be a law of cosines. So now I got to be familiar with the law of cosines. That's the big long one. I know on the end is going to go cosine of the only angle I know, which is 48. And if that's on the end, if cosine 48 is on that end of this big long equation, what's over here all by itself? H squared. Because the side that matches the angle is the one that's over here all by itself. There's only one number on this side of the problem, and it is the side that matches the angle. Now, what's all in the middle?
two other sides.
The two combinations of the two other sides. So it's 16 squared plus 18 squared minus 2 16 18 cosine 48. So whatever the other two sides are, in this case 16 and 18, 16 squared plus 18 squared minus 2 times 16 times 18 times cosine 48. Now, again, you can type this in any way you want, but I would suggest that you just type it in. Since h, which is your variable, is over here all by itself, just type it in. So 16 squared plus 18 squared minus 2 times 16 times 18 times cosine 48.
Collect the money.
Now, the only thing we gotta remember is the answer that comes out is h squared. So we have to square root that. And for side h, I got 13.95.
What's the root on?
And why did I put a degree on that? Because I am a goofball. There's my sign.
Because I am
The side. So 13.95. Now we're not done with the problem. Now we gotta find these angles. But now, as Mamuna has pointed out, now I do have a pair, an angle and a side. So now I can say sine 48 over 13.95. In order to set up your fraction, you gotta have the fraction. I got it now. Sine angle over side. And then, I don't know, I need to pick one. Let's do L. If I do L, the other fraction will be sine L over 16. Now, pay attention. Some of you are signing 16. No. We sine angles. So it's sine L over 16. Now we can cross multiply. So 13.95 sine L equals 16 sine 48. Now what are we solving for? Yeah, this is a unit though. That can't be broken apart. So I'm going to divide to get this by itself.
Bless you. Just bless you.
But now how will I type that in on my calculator to actually get L? Lauren? What'd you say, honey? Second sign. I got a second sign. When it says sine L or log X or cosine Q, you gotta do second. So second sine 16 sine 48 close parentheses divided by 13.95. That's L. I got 58.47 degrees. Anybody else get that?
Yes. I do.
Now, we're not done. How do we find E? We could do the same thing. You could do it all over again if you just love doing that. But it's easy. Once you have two angles, you can find the third by subtracting from 180, right? So I got 73.53 for my third angle. And now I'm done. Now the problem is finished. All right, let's try the second one. We're going to be doing exactly the same thing, but the variable is going to be in a little bit different spot. So let's see what this one looks like. Oh, Hannah, I think that was your problem up there at the top. I think this was Harrison's problem. All right, so here we go. How do we know, I know it's on the law cosines practice sheet, how do we know this has got to be a law cosines? There's no pair. You don't have an angle. You don't have an angle, there's no way you can have a pair, right? Because a pair requires an angle. So this is going to have to be a law of cosines. Okay? So we got to pick an angle. Doesn't matter to me which one you want to find. I. We're going to find angle I. If we're going to find angle I, then our law of cosines is going to say cosine I on that end. If you were finding H, it'd be cosine H. Just pick one. Now, if cosine I is on that end, what's over here all by itself? 10 squared. Because the side that goes with the angle is the one that's over here all by itself. Now, what's in the middle? A combination of 8 and 12, right? So 8 squared plus 12 squared minus 2, don't forget that, it goes minus 2, 8, 12, cosine I? This one is harder to type in because the variable is kind of connected to everything over here. So again, how you do this is completely up to you, but I would suggest that maybe you figure out the pieces here. So we have 100, 64, 144, and then 2 times 8 times 12, 192 cosine I. Remember, the cosine I is part of this. So what do you think might be something to do next?
100 equals 208 minus 1.
So go ahead and add these two together. But don't get carried away. You can add the 64 and the 144 because they are plain numbers. You cannot subtract the 192 because it's hooked to a cosine. So that's separate. These two can be added.
108 equals negative 192.
So Sam is saying subtract the 208 from both sides. Does that make sense to everyone? You cannot combine these, so he subtracted this over. And now we will divide. Well, we got to divide first. Negatives cancel. And now, since that's cosine I, we have to second cosine. 108 divided by 192. I got 55.77. Sean, what are you doing? I am having a bad, awful day. I have all these kids without lanyards. I got texts arguing with me about a non-uniform item, and now you're on your phone. Someone's calling during the most important class of your day. Phones are off limits. All right, 55.77, anybody else match that? All right, now, if you feel really good about that and you like that, could you repeat that process for, let's say, H?
Oh, yeah.
You absolutely could. So if you want to do that, you can. There's nothing wrong. You're going to show your work so I know what you're doing. What else could we do now, though? If we didn't care for all that, we could do the law of sines.
I'm confused on how you got 55.7 on my calculator.
How we got what?
The 55.
Second cosine this fraction. Second cosine 108 over 192.
Oh, okay,
All right, so now I'm going to set up my law of sines. So my fraction's going to look like sine 55.77 over 10, because that's the pair that I have now. And that's going to equal what? Sine f over 8, or sine h over 12. And you're going to show your work, because we might not match exactly because of the round off error here. But as long as you're showing your work, it's fine. As long as I know what order you did things. So, 10 sine f equals 8 sine 55.77. Now, this is what I want to figure out. So I'm going to divide by 10. Now, you're just going to type that fraction in. Will that be your answer? No, because this says sine f. So in order to get your answer, you're going to have to do what? Second sine. So you're going to type that fraction in, but you're going to second sine it first. So second sine, 8 sine, 55.77, close parentheses, divided by 10. I got 41.41. That makes my H 82.82. That's kind of cool. Now, if you're close to that but not exact, it's because you found H first. And that's okay. I gotta see it. It'll be 82 point something. Yeah, and that's fine. And then this one's going to be off a little bit then because of the subtraction, but I have to see your work. Without any work, I'm not giving you credit. So you got to write down so I know what order you did things.
So I did like H first, and okay, Solomon, you did H first, right? So I got 4 cosine H equals 144. Is that what you got? Like, towards, because so I did 12 squared equals 8 squared plus 10 squared, and then all of that. And then how would I like do
Okay, I'll have to look at it individually. Okay?
Okay,
Because something's not right because that doesn't make sense. 4 cosine H can't equal 144.
Yeah, that's
Yeah,
what I was
so no. I divided both sides by 10. That wasn't there. I cross multiplied and got 10 sine f equals it. So then I divided by 10 to get sine f by itself. Because that's my variable. Yep. Okay, now tomorrow you'll get one problem. So it's going to start with the law of cosines, and then probably you'll go to the law of sines. All right. We clear on that?
Or notes.
Yep, now we're going to our notes. And some of this I already have videoed. I'm going to go and video it again. We're switching gears now and going to talk a little bit about areas and volumes. So, you will need another note card. You don't have to use a physical note card. You can use a piece of paper in the size of a note card. But you'll want to have this note card because we're going to have a bunch of different area and volume formulas. You used all these in geometry and probably even memorized them, so if you don't want to use note cards, you don't have to. However, on the note card goes only the formulas, okay? Not other notes, not other pieces of information. So, area of triangle equals formula. Area of sector equals formula. That's what goes on this note card, all right? So, here's what we're going to do. We're going to start with this first problem here that says, find the area of this triangle. Now, we actually had a quiz the other day where you had to find the area of a triangle. What, I think everybody got it right, actually, except for labeling maybe, everybody got it right. What makes this one different? What is different about this?
It's not a right triangle.
You don't have a right angle in it. And remember, to use the formula that you are familiar with, 1/2 base times height, you've got to have somewhere in your triangle, you got to have that right angle. So if it happens to be the sides of the triangle, that's fine, but base and height are perpendicular. You have no perpendiculars in this problem. So you're not going to be able to jump in and do 1/2 base times height. Now, if you want to construct a perpendicular and figure out how long that is and go to all that trouble, you can. But luckily for you, there is a very useful other formula for triangle areas. That formula is 1/2 side, sine of included angle. Now, when I talk about this formula, where you use it over and over again, I'll say 1/2 side, sine. So remember SSS, 1/2 side, sine. Does everybody remember from geometry what we mean by the included angle? So, the angle what? Between them. So if these are your two sides, this would be the included angle. If these were your two sides, this would be the included angle. So you, in order to use this formula, you must have two sides and the angle in between them. Got it? Two sides and the angle in between. If you have that, it is a super simple formula. The area for this triangle would be 1/2, 120 times 240 times sine 130. That's the only work to show. There's nothing else to show. We go to our calculator, type it in. 1/2 times 120 times 240 times sine 130. I got 11,031.04 square meters. Is that what you got when you typed it in? Hunter, is your hand up?
Is it always going to be sine?
1/2 side, sine. That's the formula. Now let's look at the next one. What's going on here? It's an equilateral triangle. What do we know about equilateral triangles? All the sides are equal and the angles are 45 degrees?
Yeah.
No.
60.
They're 60.
Yes.
Remember, in a triangle, equal sides mean equal angles. So if you have equal sides, you got equal angles. If all three sides are equal, then you're going to have all three angles equal. Since they add up to 180, each of these has to be 60. If you've forgotten some of these fundamental concepts, try to get them back up here, because you're expected to know that the angles of an equilateral triangle are congruent. Then you need to figure out their 60, because they have to have the 180. So, can I find the area of this triangle now? Very easy. 1/2
All at the same time.
side times side times side. So 1/2 6 sine 60. One half.
Oh, you'd be so dead on
I got 15.59, and that is square inches.
that.
Remember, our areas and volumes are going to have units on them. Mr. Burkhart.
Is it always gonna be 60 degrees for equilateral triangles?
Well, remember, they gotta add up to 180. And if they have to be equal, yeah, that's right. That's right. Okay. Next one. What do these little hash marks mean there? Equal, congruent. So this triangle is isosceles. It has two congruent sides. Do I know anything else about it? I think I do. Mikey? Exactly. Remember, congruent sides mean congruent angles. So if this side is 61, or if this angle is 61, then this angle is 61. The base angles of an isosceles triangle are congruent. And then we know that this one right here has to be 58. How do I know that? They add up to 180, right?
And then how do we find the side?
I don't know. How do we find sides?
The law.
Law of sines or law of cosines?
Law of sine.
Since I have this, we'll use the law of sines. So sine 58 over 12 equals sine 61 over r. They're exactly the same, so it doesn't matter which one you set up. So we'll cross multiply. So r sine 58 equals 12 sine 61. Now you're solving for r, so we'll divide by sine 58. Do I need the second sign or anything like that?
No.
Nope, just type it in. 12 sine 61 divided by sine 58. I got 12.38. Now, is that the answer to the question?
No.
No. Because we're supposed to be finding the area. So what do we know about area? It's 1/2 side times sine of included angle. So 1/2 times 12 times 12.38 times sine 61.
Yay.
And I got 64.97 square feet if I type that in wrong. Or right, if I typed it in right. Anybody else get that? Now that was an easy problem, but we had to do a lot of work to get to the point where we could find the area. So, a couple of things to remember. In a triangle, if sides are congruent, there's going to be congruent angles. So 2 sides meant 2 angles were congruent. The base angles of an isosceles triangle are congruent. We were missing a side. In order to find the area, we needed 1/2 side sine. So to find that missing side, we had to do our law of sines. Then we could actually find the area. So much work. All right, let's look at the next one. It's another triangle, and we're going to find the area. You've got 2 options here. And since you have a note card, I hope you'll use the easier of the 2 options. So one option would be to do the law of cosines to find an angle. Because that's what we need, right? If we're going to do 1/2 side sine, we need an angle. So we could do the law of cosines to find one of our angles. But in your notes, I left 2 blanks for the area of a triangle. And I didn't mean for you to put in 1/2 base times height. You don't need a note card for that. Your first new area formula is 1/2 side sine. The second area formula I would like you to put on your note card, just because it's so handy, is this. Now you're going to look at it and you're going to be like freaked out, like, oh my gosh, what in the heck does that mean? Well, let's write that down in your notes up there or on your note card if you're writing on a note card. Write that down. That's the area of a triangle. This is still a triangle. Now, what is the perimeter of this triangle? What's the perimeter of it? 34. All right, so to use this formula, you got to figure out the perimeter. And then the semi-perimeter. Any idea what that means? Semi? Half? So the semi-perimeter of this triangle is 17. And that's the S in the formula. So the S in the formula is the semi-perimeter, which is half the perimeter.
Did you get it? Okay.
Now, what do you think the little a, little b, and little c are? Sides of the triangle. So your area is going to be 17 times 17 minus 7, 17 minus 12, 17 minus 15. Do you think the order of any of those matter? No.
No.
You just got to subtract each one from 17.
Can you explain how you got 1734 again?
How do you find perimeter?
Yeah,
Yeah. So perimeter is 34. And semi is half of it. All right. So now I got to figure out what all this is. So it's going to be 17 times 10 times 5 times 2. So I got 1,700. And then what do I need to do to get my answer? Square root that. So the area of this triangle is 41.23 square meters.
Did you just type it all?
You can do that all in one step. What have I said all along?
You don't care.
I don't care how you got to show me what you're doing, but then I don't care how many steps it takes you to do that. So absolutely. But you got to come up with that. Now, that is so easy. Unfortunately, it only works if you have what information? What do you
All the
need?
sides.
Yeah, you gotta know all the sides. If you don't have all the sides, then this is not a good formula to try to use. But if you happen to know all the sides, that's slick. This thing is called Hero's formula. And the guy's name was actually Heron of Alexandria, so it's been abbreviated to Heroes, but his name was actually Heron. I think there was one R. But it's called Hero's formula. So when somebody talks to you about Hero's formula, they're talking about this area of a triangle formula. Isn't it amazing? They did all that without calculators, without anything. They just discovered that.
Okay, that's great.
Gives you a whole new
Yeah,
appreciation for how
what are you
smart
doing?
those guys were.
Well, honestly, how
This
did
was
your
just-
brain just do
just
that?
like-
This was a long time ago these guys were doing
But they
it.
made it up.
All right, now we got a parallelogram. Now we're gonna find the area of the parallelogram.
But we have two sides and an angle.
Oh, now wait, are you hearing what Izzy is saying? She said, Mrs. Ford, we have two sides and the included angle. So that is helpful to find the area of a triangle. So if I drew in a diagonal, this would be a triangle, right? And I could find the area of the triangle. It would be 1/2 14, 19 sine 63, because it's 1/2 side, side, sine. Now, that was not going to be the answer to the question, but that is going to be the area of this triangle, right? Now, we remember that parallelograms have opposite sides congruent, so that would be 14 and this would be 19, agree? And they have opposite angles congruent, so that's a 63, which means what would the area of that triangle be? Same as this one. So instead of doing 1/2 14 times 19 times sine 63, I'm just going to do 14 times 19 times sine 63, because don't I need two of these? So the area of the parallelogram is side times sine of included angle. Or you can do each triangle and then double it, or do a triangle and then double it if you want,
Wait, so the halves drop off?
because you're doubling it. So if that's, since you have a note card, I think that would be okay. But if it's going to confuse you, forget it. You can always find the parallelogram by taking one of the triangles and doubling it. That will work every time for your parallelogram. So my answer is 237.01 square centimeters.
Wow. So much funness happening.
Can't even imagine. Look at the next one. You think you've had fun so far. This is really wonderful.
If I turn over this page.
Oh, Lordy. This is where my grade goes.
Nope, this is easy. Now, what we have in problem F, the next problem, right, is F. What we have here is what we call a regular hexagon. What does hexagon mean? 6 sides. So we've got 1, 2, 3, 4, 5, 6 sides, right? And it's been inscribed or drawn inside of a circle with a radius of 9. So we got the hexagon inside the circle with the radius of 9. So I marked that one,
They're all
but would all of these be 9?
Yeah.
So basically, they're all 9s. Okay, so these are all 9 inches. So we've got 6 triangles, right? And all those triangles are congruent. Now I know my picture's not very good, but this is a regular figure, so everything's congruent. So this triangle is the same size as this one, this one, this one, so on. So if I could find the area of the shaded triangle, then the area of the whole figure is times 6. So that's a triangle. What more information do I need to be able to find its area? I need this angle right here. Would you agree with me? Now, this is not a great mystery, you guys. There's 6 of them, right? And all together they add up to 360? Around the circle, 360? If they all add up to 360 and there's 6 of them, and they're all equal, then each one of them is 60. Now, the next problem we do is not a hexagon. It's a pentagon. So that angle, we're going to divide it up into triangles, but the angles in the center aren't going to be 60. Because we got the 60 by 360 divided by 6. Well, if it's a pentagon, we're going to do 360 divided by 5. Right? If it's a decagon, we're going to do 360 divided by 10. Right? So don't think the angles are always 60. Shiloh?
So there wasn't like any direction, so when we see this picture, we're just finding
The area. You're finding the area of the shape. The directions say find the area. So we're finding the area of the hexagon.
we're not done.
Oh, we are not done,
Okay,
no. Because now we need to find the area of the triangle. We're going to start with the triangle, and that will be 1/2 9 times 9 times sine 60. And then the area of the hexagon will be 6 times the area of the triangle. So, let's find the area of the triangle. 1/2 times 9 times 9 times sine 60. Did you get 35.07?
Yeah.
Okay, don't write it down, just hit times 6. That way you don't have any round off error. So the area of the hexagon is 210.44 square inches.
Yep.
Got it? Work on the pentagon. Work on G by yourself or with your teammate and see how much progress you can make. You're going to do it exactly the same way, only it's a pentagon.
I promise I'm not stupid.
Come on. We got this. Solomon? Come on, we got it. All right, so you've got your pentagon all split up, I hope, into triangles.
Yes.
And you know that to find the area, you need an angle, preferably that one right there between the two sides. So we know all of these add up to 360. So each one of the 5 will be 72. So the area of your triangle is 1/2 10 times 10 times sine 72. So 1/2 10 times 10 times sine 72. And then that's just the triangle. You'll write it down, hit times 5. So your area is 237.76 square centimeters. Now, we did a hexagon, we did a pentagon. We could do a decagon, we could do an octagon. They're all done exactly the same way. Okay? Well, the next one is not a regular polygon.
I don't think we're both.
Yeah.
Guys, you're being rude. The next one, we're to find the area of the shaded region. And you might call this a piece of pie. No, it's a piece of pie. The actual name for it is sector. So we are going to talk about how to find the area of a sector next time we're together. So that's where we'll start.
I'll just go right in because I didn't do anything.
Area of the sector. All right, quiz tomorrow over law of cosines.